We will now review some of the important and most used data cleaning functions in Pandas. By the end of this video, you should be able to explain why there is a need to clean data, describe data cleaning as an activity, and leverage key methods Pandas provides for data cleaning. As we mentioned before during our data science overview, real-world data is messy. It can have problems related to missing values, outliers in the data, and invalid data, for instance, negative values for age. And in Python, we can also have records within data frames as NaN or none values. Since we get the data downstream, we usually have no or little control over how the data is collected. So we have the data we get, and we have to address quality issues by detecting and correcting them. All of these are related to making the data really ready for analysis in the end. So how do we clean? Here are some approaches in Pandas that we can take advantage of to address these data quality issues. We can replace invalid or NaN values with more appropriate values. For invalid values again, or gaps, we can also try to fill in the data instead of removing them. Here, a best estimate for a reasonable value can be used as a replacement. There can be different techniques to find the best estimate, and often domain knowledge is required to understand what would be that best estimate. For example, for a missing age value of an employee, a reasonable value can be estimated based on the employee's length of employment. An interpolation of the data values can also be applied to generate estimations of those missing values. Based on how the exploratory and statistical analysis of the dataset goes, we can also think of dropping some of the fields and values that are not important to the task. Outliers, for example, might be dropped depending on the situation. Let's quickly look at some of the functions in Pandas before we review them in the notebook. Using the replace function, we can globally change values in a data frame. The screenshot shown here shows how we can replace every 9999 with a 0 instead. Fill_NA method will replace missing values with the last known value forward and backward, meaning going up and going down in the column. If you look at the values in the first data frame shown here, the row index 1 and column 1, you will notice that the forward fill replaces the NaN value in that column with the value of row 0, column 1 in the forward fill case. So if you look at the second data frame, row 1, column 0 will no longer be NaN. It's going to be the value stored in row 0, column 0. In the backward fill, the same row gets replaced by the value in row 2, column 1. So it's going upwards in the data frame. Another function that we'll use a lot is called drop_NA, to drop the fields with missing values. So drop_NA function will drop any row or column with a missing value in the data frame. With the access 0 option, which is also the default for drop_NA, any rows with missing values will be eliminated, or it's going to be taken out of the data frame. So if you look at here, rows 0, 1, 5, and 6 are no longer in the data frame after executing the drop_NA function with access 0. With the access 1 option, any columns with missing values will be eliminated. In this case, since both columns 0 and 1 has NaN values in them, we are left with only column 2 in the resulting data frame. You can also interpolate values in both series and data frame objects. The default for interpolate function is linear interpolation, meaning the method tries to fit the values to a curve or line using linear polynomials, like the point xy in the graphic on this slide. There are other interpolation methods to pick from as well, but we'll leave it at linear interpolation in this introduction class. As a summary, there are many ways to deal with missing data, and Pandas provides many easy ways to tackle them. We only scratched the surface here, but please follow the links provided in this video for a starting point on further methods. Let's now switch to our notebook to see what we have discussed in action.